All right, the next part of these notes are talking about something called an inscribed angle. An inscribed angle is an angle drawn in a circle where the vertex of the angle is actually on the circle. Now, on this problem here, the vertex of the angle, the angle when it's drawn all the way across the other side of the arc, ends up being smaller than the degree measure of the arc. In fact, it ends up being half the measure of it. So what I like to say for the formula is angle equals 1/2 times the arc. And you're going to see the word chord, so I want to talk about what that means. A chord is a segment connecting 2 points on a circle. And there's some other segments too that we're going to be talking about, but basically segment AB and segment AC or BC represent 2 chords. And if they meet where the vertex is right on the circle, they have formed what's called an inscribed angle. So the angle is always half the arc. I want to kind of show you visually what that is, because you're going to see a lot of inscribed angles, and you just want to understand the relationship between the inscribed angles to the intercepted arc and the central angle. So if you don't mind, let's kind of dig into a little bit of a measurement so you can visually see what's going on. So say I have a central angle in a circle, and I measure that angle, and I get about what appears to be 83 degrees. It might be a little bit off, but let's just say that's about 83 degrees. If I take an angle, and if I'm very careful where I draw that angle to the edge of the circle, using that same arc, so it's intercepting the same arc, implying that this arc is 83 degrees since that's the central angle. Well, that angle does become smaller. And if we do a quick measurement, if I did this drawing halfway decent, it should be about half of 83. So if I measure that, it looks like I'm getting about 41. Let's check that. So this would be 10, 20, 30, 40. Looks like about 41 degrees. Now it's 41 and 83 are pretty much half. 41 is pretty much half of 83. So the measurement was pretty decent, but that kind of solidifies that anytime I draw an angle to that same arc, no matter if it's up here or down there or wherever, these two angles are both going to be the same. In fact, if that's 83, that technically would be about 41.5 degrees. 41.5 degrees, and I could keep going all the way around the circle and get a 41.5 degree angle. That's half of this arc. So let's apply that to a couple different problems. Question 7, it says in the diagram of circle O, the measure of angle RTS is 38 degrees. Well, RTS is on the circle, so that's inscribed to that arc RS. It wants to know the measure of arc RS. Well, since the angle is half the arc, that means the arc is twice the angle. So I can basically say 2 times 38. And 2 times 38 is going to be 76. So I know arc RS is 76 degrees. And furthermore, if I were to draw that central angle to O, that would make a 76 degree angle there as well. So that's the relationship between the inscribed angle and the arc. See if you can figure out number 8. Pause the video and try it yourself. Well, number 8 is actually kind of interesting. It's actually pretty much the same problem, isn't it? The only difference is that it's got the same angle degree for angle ABC, but it wants to know the central angle, not the arc. No biggie, because if I take that 38 and times it by 2, that's going to give me 76 again. But this time I want to know the angle measure, which is the central angle in this case, since O is in the center of the circle. So the measure of angle AOC is also going to be 76 degrees. In question 9, in the diagram, isosceles triangle ABC is inscribed in circle O, and the measure of angle BAC is 40 degrees. Find the measure of arc AC. Okay, so I want to know that arc measure. I know that it's an isosceles triangle, and isosceles means two equal sides. So that means angle A or segment AB and AC are equal, congruent to each other. Also, the base angles are going to be congruent too. So I can actually figure out what the base angles are because the three angles in a triangle add to 180. So if I subtract 40 from 180, I'm going to get 140. And if I divide that by 2, that's going to give me 70 degrees. That means angle C and angle B are both going to be 70 degrees. Now let's answer the question. What is the measure of arc AC? Well, let's look at AC. Arc AC is intercepted from which angle, which inscribed angle? You connect the segment connecting to A and to C. You'll find that the inscribed angle is 70 degrees. So the arc is going to be 70 times 2. So we're right back to 140 here. And furthermore, since this is 70, that's going to be 140. And since that's 40, that's going to be 40 times 2 is going to be 80. And if you do the quick math behind it, just to make sure your arcs all add up to 360, 140 times 2, or 140 plus 140 plus 80, there's your 360 altogether. And since we want to know AC, we just circle that 140 and we're done. Okay, in question 10, in the diagram, triangle ABC is inscribed in circle O. The measure of angle B is 36. What is the measure of angle A and angle C? Well, let's take a look at angle A. What do you think angle A is? Well, if you maybe turn your page, maybe put the corner of a paper up to angle A, it looks like it is a perfect right angle. Well, it turns out that it's actually exactly 90 degrees because segment BC goes through the center of the circle. So that's a diameter. And a diameter will split that circle into two semicircles, which makes the degree measure of this arc 360 divided by 2, which is 180. And if I want to know what the inscribed angle to that 180 is, I'm going to divide that by 2 to get 90. So angle A is going to be 90 degrees. Now, as far as angle C goes, we can work with the triangle. We're already given the 36-degree angle at angle B. Three angles in a triangle add to 180 degrees. So I know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And I'm gonna get C by subtracting the 36 and the 90 from 180. So let's go ahead and add those together and subtract, or subtract all at once. 180 minus 36 minus 90. It's going to get us 54 degrees. So A is a right angle, it's 90 degrees. C is 54 degrees. Question number 11. In the diagram of circle O, the ratio of BC to AB is 2 to 1. So let's do that quick. It says BC to AB. So BC is 2 times AB, which is 1. Now, this is not 2 degrees or 2 units. It's 2 times some number, and this is 1 times some number. I don't know what the number is, so let's just call that x. In order to get the measure of angle ACB, which is down here, I would have to cut the arc measure AB in half. Well, what I can start with, knowing that this is a diameter, because that goes through the center of the circle, I automatically know that this is half the circle. So I know that 1x plus 2x, their sum is 180 since that's half. So 3x is 180. And 180 divided by 3 is 60. So if I put that 60 back in here, I'm going to tell you that arc AB is 60 degrees. And arc BC is 2 times 60, so that's 120. Well, I want to know this angle down here. So that's going to be half of 60. So that'll be 30 degrees. This angle A would be half of 20, or 120, which would be 60. And this ends up being a 30, 60, 90 triangle. So once again, that's a right angle. So you could think of that as a right triangle, kind of like on the last problem. But your answer for that is 60, or 30. The measure of angle ACB, that's a 30-degree angle. Finally, number 12 on this page, it says in the diagram, triangle ABC is inscribed in circle O. Again, noticing a similar pattern, this is going through the center of the circle. So that's going to mean angle A is a 90-degree angle. And it says the measure of angle B is 5x minus 34, and the measure of angle C is 3x minus 12. What is the measure of arc BA in degrees? So I want to know this degree measure, but I have to, in order to get arc BA, I have to know angle C, so I can double that. So the measure of arc BA is 2 times the measure of angle C. So our objective is to find angle C, so we can double that and get the arc that we're asked for. First thing is we have 3 angles in this triangle, and all 3 angles add to 180. So I know that 3x minus 12, 5x minus 34, and the 90-degree angle, their sum is 180. So if I combine all the numbers, I get 8x, negative 12 minus 34 plus 90. So that's 44. Subtract 44 and you're going to get 136. And 136 divided by 8 is 17. A lot of times with x we need to plug it in. So to get the measure of angle or arc BA, again we had talked about getting angle C and doubling that. So the measure of angle C is 3x minus 12. So I'm going to do 3 times 17 minus 12. And that's 39 degrees. So arc BC finally is going to be 2 times 39 and 2 times 39, well 2 times 40 is 80, so bump it down 2 and that's going to be 78 degrees. And this would be 180, and without doing any extra math, or without solving, I can add these together and subtract from 180 to get this angle and double it to get that. So there's a lot of different things you can get from there just from that knowing x in this problem. Okay, we got a few more. This one's a long segment, so I appreciate you sticking with me. Okay, on 13, if chords AC and BC are congruent and the measure of AC is 130, find the measure of angle C. Well, if I know chords AC and BC are congruent, then it's going to imply that the arc over here at BC is going to be the same as 130. So if I want to know the measure of angle C, I know that's going to be half of arc AB. So I'm going to find AB. These three arcs add to 360. So the measure of AB is going to be 360 minus 130 minus another 130. And that's going to be 360 minus 260. So that should be a 100-degree arc. You can check my math on me for me. So that's 100 degrees. Angle C is going to be half of that. So half of 100 is 50 degrees. All right, try some of the next ones. Pause the video. I mean, I'm going to work them all out, but I want you to make an effort and see if you can figure some of these out. It's all using the same techniques about inscribed angles, triangles, and lines, and all that stuff. So with having said that, I'm going to start working on 14. If you want to pause it to try on your own, pause it. AB is a diameter and K is the center of the circle. The measure of angle CAB is 48 degrees. What is the measure of angle AKC? Well, this angle's not drawn for you, so we have to make it on our own. So what I can do, knowing that this is a diameter, actually I don't even need that information, because I can make that this is a radius right here. Well, the diameter is going to tell me that AK is a radius. Well, that means KC is also going to be a radius. So these two are equal. So I know that the measure of angle ACK is equal to 48 degrees because that's an isosceles triangle. So if I want to know the measure of angle AKC, I'm going to use my knowledge of triangles and solve for the missing third angle in a triangle. So the measure of angle AKC is 180 minus 48 minus 48. And 48 and 48 give you 96. And 180 minus 96, what's that? I'm getting 84. So missing angle here is 84 degrees. And that also tells you, since that's in the center of the circle, our AC is going to be 84 as well. Okay, keep trying some of these on your own. Pause the video, see if you can try to get the missing angles and arcs in number 15, 16, 17, 18. We'll work through as many as we can together. I want to get angle A here. That's an angle, so that's going to be half the arc it intercepts. And it intercepts the arc that's 140 degrees. So I'm going to take 140 and divide by 2, since that's an inscribed angle. So half of 140 is going to be 70. Letter C is an arc. And that spans the distance between this line and over here where the 70 is. And that arc is intercepted by the angle 36. So since I want the arc, I have to multiply by 2 to get the arc from the angle. So C is 2 times 36. So C is going to be 72. And to get angle B is a vertical angle to the angle in that triangle. You should know that two angles that intersect are going to be the same measure. So whatever I get for this angle here, I'm going to have that as my answer. Well, I'm again dealing with a triangle, so we have this angle is going to be 180 minus 36 minus 70. And that's going to be 180 minus 106. And that's going to give us what? 74. Is that right? So 74 is going to be that angle, which implies that angle B, since that's vertical, is also going to be 74 degrees. So A is 70, B is 74, C is 72. Okay, number 16, we got some missing angles as well. This angle down here at A is going to form a linear pair with the 130. And two angles that form a line, you should know, add to 180. So A is going to be 130 minus, or 180 minus 130. So A is going to be 50 degrees. That's an inscribed angle. So now as we go out to the arc, you got a 50-degree angle, and that's going to intercept an arc, and that arc's going to be 100 because you're going to take that 50 and times by 2. Well, remember from the last little video that the central angle is equal to the arc. So that's going to be 100 degrees. Because that's the center of the circle, we have two radii formed, and they're going to make an isosceles triangle. So we can get angle B and angle C by figuring out the missing angles in these triangles. The measure of angle B is equal to the measure of angle C. And we can get that by taking 100 from 180 and dividing that number by 2. And so that's going to give you 80 divided by 2, which is 40 degrees. So B and C are both going to be 40. D is 100 and A is 50. Okay, we're going to revisit number 17. I threw this problem at you on the first lesson of the unit. That's the questions in the diagram. CB contains the center of the circle. If it contains the center of the circle, even though the center is not drawn, we assume that CB is the diameter. The measure of angle ACB is 35 degrees. And arc AC has an arc length of 10 pi. Well, AC is up here. And guys, you know that you have to use the arc length formula, so it's going to be L equals 2 pi r times degree of the central angle over 360. we got our 10 pi, we got our L, we are going to get our degree, we're going to try to solve for the radius. Since it wants to know what is the length of CB, CB is the diameter, so CB is going to be two times the radius. So whenever we get CB, we're going to double that, and or the radius, we're going to double that and get CB. So let's start by solving for the radius. We're going to get our degree measure by taking that 35 and timesing by 2. That's 70 degrees. And because this is a diameter, that means that this angle, this arc measure in degrees is going to be plus the 70 give you 180. So that's 110. And the central angle that opens up to that arc is 110. So we know the degree of the central angle now. It's 110 degrees. So we know the length, that's 10 pi. So we have 10 pi equals 2 pi r times 110 over 360. Well, we can cancel out the pi's on both sides. So I have 10 equals 2 times r, 2r times 110 over 360. I would divide by 2 on both sides, so it's going to be 5 equals r times 110 over 360. And then I would multiply the 5 by 360 and divide by 110. Multiply by its reciprocal. And I don't know what that is, so I'll use my calculator. And I'm getting a decimal, so I will say 16.36 units. So what would C be equal? Well, remember CB is the diameter, that's twice the radius. So CB equals 2 times 16.36. And that's going to give me 32.73. Finally, on this inscribed angle set of problems, we're talking about a diagram where we have another inscribed angle and its measure is 40 degrees. So it says the inscribed angle ABC, that's over here on the left, that's 40 degrees. The radius of the circle shown is 8 units. Now we don't have any radius drawn. It says what is the arc length of arc AB? Well, first thing I know is that arc AC is going to be 2 times 40, okay? So 2 times 40 is 80. And what I want to figure out is the degree of that central angle. So that central angle is here. Well, I know that these two are equal to each other. So if I subtract the 80 from both sides, from 360, and divide that by 2, I can get the measure of arc AB. .360 minus 80 is 280 divided by 2, which is going to be 140. So those are both going to be 140 degrees. And 140 plus 140 is 280. Plus another 80 should get us back up to 360. Well, now I have the degree of the central angle. I have the radius. I can plug it into the length formula again. So L equals 2 pi r times degree over 360. 2 pi times 8 times 140 over 360. And let's round that to the nearest hundredth. So 2 pi parentheses 8 times 140 over 360 is about 19.547. So 19.55 is fine. And that's going to be units again. So arc AB is 19.55. Okay, that concludes the inscribed angle video. I know that was a little bit longer, but hopefully those examples help you understand it, and we can move on to the next stuff.